Hi guys, in this video we're going to go over the different types of functions that we will cover in precalc. You should have seen a lot of these before, and we are not going to completely fill out this graphic organizer, but we're going to start it. So go ahead and pause the video and draw the graphs that you can see. All right, constant functions are usually seen as a part of a piecewise function. But a constant function is basically just those horizontal lines that have the same y values. Every single point has the same y value. So for mine, because mine is up at 2, this would be the line y equals 2. If I were to look at a table of values, the y column would say 2 all the way across. So the domain of this function, domain describes the x values from the left to the right. So there's an arrow to the left and an arrow to the right. So the domain is negative infinity to positive infinity, which I am a little bit of a lazy writer. So that fancy R means the same thing, the set of all real numbers. Now for this, because this is constant, the y's are only 2. My range is simply describing the y values, which for this function is just 2. All right, linear. Linear has a constant rate of change. You should remember the slope from Math 1. So when you're looking at a table of values of a linear function, you would be looking for an addition pattern where the rise over run was the same between every set of points. There's an arrow to the left and an arrow to the right, so the domain is all real numbers. There's no restrictions. The range, this goes down to negative infinity. The rest of the graph goes to positive infinity, so the range is all real numbers as well. All right, quadratic. Quadratic has the x being squared. So what you're going to notice a lot of times in the table of these, you have to take the x value and square it. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, but just take the number that's in the x column and square it. One key feature that a quadratic has, which is the graph of a quadratic is called a parabola. So if you hear me say the word parabola, that means we're looking at a quadratic, is the vertex here. The vertex is either a max or a min. In this particular case, it's a minimum because it's at the bottom of the graph. But the vertex is going to help you figure out the range of your graph if it's quadratic. So domain, arrow to the left, arrow to the right. The domain is the set of all real numbers, but my range is limited by that vertex. The range always goes low to high. So the lowest y value of this graph is 0, and then it extends up to infinity. We use a bracket whenever there's an actual point, so that number is included in the range. All right, cubic. If you're analyzing cubic from a table, you'll be taking the x value and cubing it, so raising it to the third power. So negative 2 cubed would be negative 8. Negative 1 cubed would be negative 1, 0, 0, and then you would continue just raising whatever's in the x column to the third power. Arrow to the left, arrow to the right. Domain is all real numbers. Arrow going down, arrow going up. Range is all real numbers. All right, absolute value, you can recognize the equation because it's in the bars. And absolute value is technically a piecewise function where both of your pieces are linear, which means we're going to be adding the same amount each time. The only difference is the y values have to be positive. So this is basically like a one-to-one relationship almost. This is saying that the y value is equal to whatever the x value is, only if the x value is negative, because absolute value means you take the positive value. So negative 2 would be 2. Negative 1 would be positive 1. and then +1 would be +1. So you're going to notice the y number and the x number should be the same, with the exception that your y's are all positive. All right, domain, arrow to the left, arrow to the right, no restrictions. All real numbers. This graph also has a vertex. So again, we're looking for a maximum or a minimum, and that's going to limit the range. This is going to be the same range because the vertex is in the same spot. 0 is the minimum y value, and the arrows going up extend the y's to infinity. All right, so again, go ahead and pause and graph the ones that you can see. All right, one of the features that an exponential function has that the others don't all have is a horizontal asymptote. A horizontal asymptote. So the domain is still all real numbers, because we can go negative infinity to positive infinity. There's an arrow to the left and an arrow to the right, and there's no restrictions. That means for this equation, you can plug any number that you want in for x. But the range is limited. It's being restricted by this horizontal asymptote. So this horizontal asymptote is the line y equals 0, because all those points would have a y value of 0. So that's my lowest y value. The rest of the graph is above it, and it goes up for infinity. But because an asymptote is not an actual like minimum point, 0 is not included. That function is approaching 0, but it's never going to actually touch. So we use a parenthesis to mean that's as close as it's going to get, but it will never actually reach it. All right, now rational has, typically, not all the time, but it also has a horizontal asymptote, but it also, on the parent function at least, has a vertical asymptote. So the horizontal asymptote restricts the range, the vertical asymptote restricts the domain. This is the line x equals 0. The horizontal asymptote here is the line y equals 0. So you can see that there's some restrictions here because your graph is literally in two different sections. It's not continuous, which means there's a gap somewhere. So the reason that I have something going on at 0, because you cannot divide by 0. So whatever number is going to make your denominator 0 is not a number we're allowed to use for x. So the easiest thing to do, we're going to say all real numbers, because there is an arrow to the left and an arrow to the right, but we say what x is not allowed to equal, and that's just a little bit faster. So in this case, x is not allowed to equal 0. And I meant to do that green so that you had the association between the vertical asymptote. All right, same thing for the range. There is an arrow down and an arrow up. So all real numbers except for y is equal to 0, because we have to jump over that horizontal asymptote. All right, square root function. Square root function has this point here called your initial point. And that's going to help you figure out what your domain and range are. So that initial point, let me kind of color code this a little bit. For my particular point, this is the parent function. So that point is at 0, 1. That's the, oh, sorry, I'm going to write 0. It's at 0, 0. I just can't read my graph. So that initial point is at 0, 0. So domain is always left to right. It describes the x values. So the furthest to the left that this graph goes is 0. And then it has an arrow to the right. So my domain is 0 to infinity. 0 gets a bracket because that is an actual ordered pair on the graph. Range goes from low to high. All right, so again, that 0, that is the y coordinate of that point. That's the lowest that this graph goes, and then that arrow does extend up. So the range is also 0 to infinity. All right, piecewise functions, we're not going to get into the domain and range of piecewise functions just now, but you should be able to recognize the equation because it actually has multiple components. You should be able to recognize the graph because, like, I can identify these two are linear, but they are two separate linear equations. All right, the trig functions that we're going to focus on are sine and cosine. So they have this wavy pattern. These are called periodic functions. So periodic functions means it's going to continue that wavelength pattern forever and ever and ever. So the domain is all real numbers because even though like we technically don't have an arrow going to the left, that wavelength will continue to the left and that wavelength pattern will continue to the right. The range is restricted by whatever these little minimums and maximums are. Those should be the same all the way across the graph. So the minimum y value on the parent function is -1, and the maximum is 1. They get brackets because those are actual points that are on there. All right, so we will complete the rest of these notes when we meet together on Zoom. Please bring these with you and be sure you have filled them out. Also, you should use these notes to help you with the Desmos activity that goes with today's assignment as well.